On this video, we're going to have ambiguous triangles as our subject of choice. And ambiguous triangles goes with the law of signs. Now, the word ambiguous means unclear because multiple interpretations are allowed. So, examples in language is anytime that a word is used that you could take it one of two ways. I know you know this from just talking to people because a lot of people get offended when that's not what you meant. Okay, that's an example of being ambiguous. In the case of triangles, this comes when you have one triangle that has a certain length allowed and a certain angle, and it will always be in the form of two sides and one angle, where the two sides are side by side and the angle is by itself. And this ambiguous triangle is able to be drawn in two different ways. And here I have it drawn in the black line and then the alternate version in the red line. And I know I've been saying in class that there's a way that we can keep up with having multiple triangles and still only use A, B, and C. And the way I've been talking about is this little prime thing that I have drawn on here. That little apostrophe next to the B literally means it's B, but it's actually the other B. Same spot, different number, because I'm talking about a different triangle on the same graph. So this new ambiguous triangle, let me retrace it in gray, actually goes in here and then back, and so it looks more like a flatter wedge, I guess. So how do we tell if a triangle is ambiguous? Well, first of all, again, you got to check for the situation. You're going to have one angle over here. You're going to have a side labeled, and then you're going to have another side labeled. And so you can see this kind of goes as side, side, angle. And don't spell that backwards. I'll get in trouble for it. So in order to prove that this is an ambiguous triangle, I first need to use the law of signs to figure out what angle C actually is. So yes, in solving this, I am skipping some steps because this screen is really small and I need to get more room. And so I first get that C is equal to 53.1 degrees. And I can use this number now to solve for B, 180 minus the 30 degrees minus the 153, or minus the 53.1 degrees. And I get that B is equal to 96.9 degrees. No big deal, right? We've been doing this. Now, what about if the triangle is ambiguous? Well, since I have it in the side-side angle format, I have to assume that it is. So here's my C prime, here's my B prime. And here's where the trick really comes in. This angle here that I'm drawing now has to be the same angle as the original C, because these two lines here and here are congruent. And if you remember from geometry, this is an isosceles triangle, which means that not only are these two lines congruent, but these two angles have to be congruent also. Now, if you, again, remember from geometry, the angle of a straight line is 180 degrees. And this is what I'm going to use to find my ambiguous side of my triangle. So C prime is going to be equal to the 180 from the straight line minus the 53.1 degrees that's on the back side of C prime. And this will give me an answer of 126.9 degrees. And hang on, I should have put degree there. Degree, there. Now I can use this new C prime to find the new B prime, the same way I found the original B, because a triangle is also allowed 180 degrees, minus the 30 from A, minus the 126.9 from C prime, and this will give me an angle for B prime of 23.1 degrees. So you can see I actually can make two separate triangles on the exact same graph using the exact same starting information. This is the very definition of ambiguous. There's two possible answers because I never said which one I was using. What if it's not ambiguous, though? I could still give you a situation where I give you two sides and an angle, and it won't actually be ambiguous, so how can you tell the difference? So let's first draw our triangle, label it ABC, and let's go ahead and solve for angle C. Now once again, yes, I'm skipping steps, small screen, sorry, I can explain it in more detail in class. So I get that angle C is equal to 23.6 degrees. Now I'm not going to solve for B because I really don't have to in order to prove that this is ambiguous. I really only have to find C prime and B prime. So drawing my extra line for my ambiguous case, which may or may not be actually possible, I have the C prime is equal once again to my straight line 180 minus the 23.6 degrees from C, and that gives me 56.4 degrees. B prime has to equal the 180 degrees for the entire triangle minus the 30 from A minus the 30 from C prime, or sorry, the 156.4 from C prime, and this will give me a negative 6.4 degrees. There. How can you have negative 6.4 degrees in a triangle? Well, the correct answer is you can't. It's impossible. Which means that this negative number means that my triangle is not ambiguous. Even though I gave you a side-side angle situation, this exact triangle, because of its dimensions, is not actually ambiguous. But you would have to test in order to know that. So that's the end of ambiguous triangles. Remember that anytime you are given two sides and an angle, so again, that's side, side, angle, don't spell it backwards, that you have to test whether or not the triangle is ambiguous. You must test every single time. If you don't, then you risk getting the wrong answer or not getting enough answers for it to be correct. We will go over this in class. I guarantee you one of these triangles will be on the next test, so pay attention. Go back and look at your notes, review what this video has been over. If you have not taken notes, then go back and watch the video again so you can actually do your notes. And I will see you in class tomorrow. Later.